Hey everyone, welcome back to day 2 of the Build Your Own Tezos Token workshop featuring MadFish Official and the wonderful Anastasiia from MadFish, the lead developer for the QuipU Swap Exchange. Hey everyone, welcome back to day 2 of the Build Your Own Tezos Token workshop featuring MadFish Official and the... Had several windows open there, so sorry about that. Quick little update on the competition. We got the Bitcoin Suisse crypto certificates in for you guys. So 3 of you with the best idea for a token and token platform will be, well, since it's Corona, you're already home, so you'll be getting them at home, loaded with some XTZ. So keep it in mind, take a look at the framework, and ask away in the questions in the chat. Feel free to ask as much as you want. There's no bad questions. Maybe bad answers, but not a bad question. So without further ado, Anastasiia, the floor is yours.
Thank you. Actually, looking at how you struggle with homework, I realized that I need to slow down, and explain some basic things. I really appreciate the questions in the chat. That's why I will start with answering to them. First of all, I saw the question, who executes the smart contracts? First of all, you should realize that smart contracts are executed in the blockchain by nodes. So when someone sends a transaction, the node loads the code of the smart contract and push like your arguments in the storage of the smart contract above this stack, and then execute the code and stores the result to the storage of that smart contract. Yeah. What is the lifetime of the execution of a smart contract? I'm not sure that I understand this question properly, but I will try to explain you how smart contracts actually work. They are not executed all the time. I mean, they are executed when someone sends the transaction, and then the transaction is executed and the storage is updated, or some other operations are generated and then they are executed, and few smart contracts update their storage. Next, why do we need to store the storage inside the business logic of a smart contract? If the smart contract does not have any storage, or it's just a stateless smart contract, it mostly does not have any point, because there is no need in doing something inside smart contract if it does not have any impact on the network. The only way you can use this smart contract is to generate some other operations to other smart contracts, but indeed you can do it just outside of the blockchain and just sign few transactions. Can we split a smart contract to 2 or more? Yes, sure. You can have a set of smart contracts that have some logic inside them, and they can be connected by some other operations. And how big can the storage of a single smart contract be? Well, the storage is really limited, and I have faced limits of it, but I can't recall the exact number. I can say that you really can find this limit, as well as you can find the gas limit. That means how many operations can be executed during the single transaction. And you can face the type length limit. So it's all really possible to see. And maybe you have any other questions, some basic questions that do not relate to the code. You can ask me now in chat, I mean. All right, I can see any questions, so we can proceed. I have prepared, let me share my screen. By the way, can you hear me well? Like, is all right with the connection, and can you see my screen right now? All right, that's great. Cool. So we can go to our homework. Let me open the project. I will recall you that your task was to implement two functions, mint and redeem. The mint function have to receive some XTC and then increment the balance of the users that have sent them. And then another function was redeemed that had to decrement this balance and send the XTZ back. I have declared two types, redeem type and mint type. Redeem type receives the amount of tokens that have to be that has to be withdrawn. And mint type receive nothing because we do not need any parameters. We can read the number of XTZs that have been sent by the user using the global Tezos amount variable. And as I said, I add a few subtypes to our action, mint, redeem, and default. As you remember, there was a special extra task that you must to do if you wish to get an extra score. And you have to proceed simple transfers to the contract as their mint function. That means that someone can not just invoke the smart contract, but send XTZ to that, and you should recognize it as a mint operation. To do that, you just needed to add default entry point, and it would work. Because the simple transfer, it's the same as calling default entry point. And I have added these three subtypes to my router, to our main function, and invoked some functions that had been declared a little bit above of this code. Mint function is pretty simple. It requires only the storage because exactly storage will be updated. Then we retrieve the account from the big map. As you remember, we have declared such a function on our yesterday lesson. I can just move to it. As you can see, we request the owner address and the storage, and we return the account from our ledger. I recall you that the storage consists of it is a record with two fields, total supply and ledger. Total supply is unsigned integer, and ledger is a big map that has a key of type address and values of type account. And this account we will need to get and return from our getAccount function. To get the value from this ledger, we need to use the construction keys of the big map, and we can receive two options because actually the type of values that is stored in the ledger is option, and we can either have the value or not. If we have no values, then we have none option, and we need to return some default value, which is balance 0 and allowances and empty map. And if we have some value, we just return it. That's it. So here we have the function that returns some account from our storage based on the key owner. Back to our mint function. We receive this value. We start in variable account. Actually, this is not a variable, this is a constant. And we use this egg to receive the balance and to increment it. That is interesting fact that this amount is of type Tez, and we cannot add two variables of different types. That's why we need to convert Tezos amount by simply dividing it by one Tez. The idea is that if we have a test type here and we divide it to another variable of type test, we will receive a natural number. And that is exactly what we wanted. And as you see, we update account balance, and we need to update the account itself, because unless we store this new modified account in the ledger, the variable is not updated. That is all about main functions that you had to implement. Yeah. And another function was redeem. Here we need an extra parameter, which is a value that user wants to redeem, and the storage, as usual. Again, we get the account from the storage using the previous function. Then we ensure that account has some balance to burn these tokens. If you don't, then we just raise an error, and that's it. Otherwise, we do some actions. Actually, it could be done a little bit in a different way. We can create the block and put everything inside of the block. It does not matter, but if you wish, you can do it. Then we update the balance, actually in the same way as in the main function, but here we should subtract the value from account balance, and in the result of this operation, we'll receive integers. That's why we need to convert it to the natural or unsigned integer. And so we use fc operation to do that. Then we update the account in our ledger in the storage, and that's about it. But we need to send some tokens to the receiver. We need to return XTZ to the transaction sender. To do that, we need to generate the transaction in the end of our redeem function. And we start with defining list. You can see it, yeah? With only one operation inside. That is transaction with data unit, which means nothing, and the value multiplied by one new test, because value is of type not, but we need to have a test type here. And we need to specify the contract that will receive the value. Actually, each basic account that is not smart contract also is interpreted like a contract, with default entry points that we were discussing before. And to get this contract, we need to use such a construction as get contract opt from Tezos sender, and expect that is an option of contracts with unit type, I would say. We either succeed in it, and that's why we will have this type to send tokens, or if a smart contract that does not have a default entry point, then our function will fail, and we won't be able to send XTZ back to the sender. And actually, that's it about the redeem function. Maybe you have any questions, I can answer them. So I guess no questions, and I can go to the next topics that we need to discuss today. Or do you have any? Why divide by one view test? Great question. We need to divide by one view test because Tezos amount is of type test. So actually, if we create some const, if we declare some const here, like let's call it value, if we don't have one, value, then it will be of type Tez. If we just use Tezos amount, then we will have type Tez here. But in our case, account balance is of type NOT, and we can't add NOT to Tez. That's why we need to divide our Tez by Tez, and then in the result of division to Tez, we will receive NOT type, and that's exactly what we need to do not have any errors or something like that. And actually, that's why we have a multiplication here, because value is of type NOT, but we need to have Tez here. That's why when we multiply NOT by Tez, we will receive the Tez. That is the reason. Well, I think it's all about the previous topic that we have been discussing, and we can go to the next. I guess, yeah. Let me just remove the new code. Yeah, it's better now. And this one. So, today we'll discuss Truffle, and we will talk a bit about migrations and testing. As you remember, yesterday we were talking a bit about artifacts and migration scripts, but I guess you do not know where these artifacts coming from. They actually are generated when we run Truffle compile. And they're stored in the folder build contracts. And you can see new code here and some information about the deployed contracts in the section network. And then if you run some scripts with Truffle, for instance, Truffle migrate or Truffle test or Truffle exec, then you will be able to have such an awesome global variable as artifacts, and you can use required to get these artifacts and then use them in your code. You can either use them to deploy this contract, or you can get the instance of deployed contract in this way, like const instance wait migrations deployed. And then you will get the instance at that address that you have deployed your contract. And you will be able to interact with it or read its storage, for instance, const storage. Like this. So you will receive the storage, and then you can read some variables from this storage, or you will be able to interact with this instance. As you remember, we do not have any specific entry point here, so we have only default entry point in case of migrations, and you would be able to call default with type integer, right? So we have only integer type here as a parameter, so it would be default entry point with 10, for instance, and you would be able to call it in this way. Don't worry, we will discuss it a little bit deeper in our test when we will create tests, but you should be aware that artifacts are really useful. And another thing about migrations is that you can deploy them not only to the sandbox, because when you run Truffle migrate, they are deployed to your sandbox, but they also can be deployed to other networks. Moreover, you can see that our network is updated because we have some deployed contracts to our network, and their addresses are stored in the artifacts. You see this address, so that is our migration, deployed migrations, and token 412 also have has the stored address of the contract. So migrations are not run because we have some contracts in our network. To force to do this, you need to type and that's the flag reset, and then contracts will be redeployed if you need it. But it's not so interesting to deploy something to the sandbox, and maybe you want to deploy something to the another network. To configure it, you need to go to truffle config and actually set up your network. It is deployment network, and you can see that it has some parameters like a host, port, network, its secret key, and type. And if you are familiar with Ethereum development, you probably know most of them, like host, port, and network. But if you deploy for Tezos network, you always must provide secret key, because if you just comment it, you will see an error. Yeah, no faucet account or secret key detected in the truffle config. And you always have to provide type Tezos, because otherwise it will be the Ethereum network will be expected. So remember about it. And if you want to add some another network, you can just do this. CartridgeNet is a little bit outdated, so we will deploy our contracts to DelphiNet. And we will just change provider. And we will need to add the secret key here. I have sent some tokens to Alice's account, so we want to do it right now. But we will try to deploy to that network. We need to add the flag network, then specify the network itself. And expect that something will happen. We can find this contract in Explorer. There is such an awesome platform as Better.Dev. Maybe it's not yet ready. Yeah, so we have the contract. And you can see some information about the deployment, or how it's called origination, in the Tezos terms. You can see the sender of the transaction, you can see the contract address and the initial storage as well, some information about consumed gas, paid fee, and blah, blah, blah. You can look at it after our session. And you can also see storage here, code, and you even can try to interact with it. For instance, we can call the default entry point with some argument. You can execute it, or you can simulate it. So there is many things that you can do with this platform. I highly recommend you to look at it, and I will send a link to this platform after the session. And yeah, we see that the second contract, I mean our FAR12 token, had been deployed too. So we also can look at it quickly. We see origination, we have the initial storage, we have some information about fee, about gas limit. That means the amount of gas that had been spent to create this smart contract, and the storage limit. So also you can just play around filters and some other things. So let's look at something, some other interesting configurations that you can add through your truffle config. One of them is contracts build directory. Let's say test. By default, contract build directory is build contracts, but sometimes you need to store your artifacts separately. For instance, you do not want to write them, so you can specify contracts build directory here, and then your contracts will be stored, your new contracts will be stored in test directory. Also, you can specify contracts migration directory, and then all the migrations in this directory will be run. For instance, if we run Tezos migrations right now, nothing will be executed, even if we type the set flag. Oh, sorry, seems like I have read something wrong. Migration directory is wrong. Yeah, one thing is unnecessary here. Sorry. It's migration directory. So this one, this time it shouldn't work. No, what's wrong? Migrations, yeah. Yeah, finally. So you can specify the directory with your migrations if you need to have another one. Also, you can specify contracts directory here. And I will show you by example why this option is the most useful in the config. Let's imagine that we want to split our contracts and, for instance, have functions and main function in separate files. Let's just copy the file and call it methods. And we will remove main function from this file. And we will remove everything except this function from this file. So here we have only main function, and here we have everything else. And to make this contract full, we will add include here with the name of this file. We will try to compile this. And something went wrong because entry point error does not exist in the tokens file 1.2 methods. That is a problem. And to solve it, we can actually add that configuration that I said before. We can specify contracts directory and say that main contracts main is the only directory that should be compiled. So we will just add the folder main here and something like partial, where we will have everything else. And we need to change the path a little bit. Now it should compile, should be compiled. Yeah, so as you can see, we have split our contract to two contracts. Actually, not to two contracts, but to two files, yeah, and just stored them in different folders. And we can compile this code. And it's all I wanted to say about migrations. Do you have any questions related to this part of the lesson? Mhm. Yes, it's possible just to make gas for contract deployment, but it's done with Taquito. Taquito is a package that can be used for other things. It's not the part of the truffle. But actually, it's part of the truffle, so you can call it. But I won't discuss it right now. And yes, you can estimate gas that you need to interact with smart contracts, and yeah, it's all possible with Taquito. Link to Taquito, you mean? Yes, I can share it. Mhm. Or do you mean better call that I have been um, shown before? Oh, sorry. So um, maybe we can go to testing part and what is that? Yeah, I need to remove it because, as you remember, we have played around it a little bit earlier. And we will add the file for our first test. Let's call it general test. And we can create the test suite here by typing contract, yeah. That requires first the name of test suite as a first argument. Let's call it token 1, 2. And the function that will contain all the tests that we need. We'll make it a sync function, and we will add the body of it. Really important thing is to understand how actual testing works in the truffle framework. When you run a truffle test, let's try it. 3 stages are actually executed. First, your contracts are compiled, as you can see here. Second, you may not notice it, but actually all migrations are done before each suitcase. I can show it by adding an extra mistake here. so that you will see that this file is used. For instance, I can just type something here, and you will see that migrations are really called, and that's why you should care what you do here, because it will be executed before your test, and then you will be able to use the contracts deployed in these migrations in your test cases. Sorry, I have some issues with the battery. I don't know why. Very weird, but all right. So let's continue with testing. As I said, migrations around before the test case, and then you can use these contracts inside of your test case. And in order to declare the specific test, you use it. I don't know why it's continuing with some random phrases here, but it, then the name of the test or the description of the test, like should check initial storage. And then we should add the function here that will contain the test body. Yeah, someone says me that the contract is misspelled. Contract, right. And actually that is the first test. And if we just run it with shuffle test, we will see that the new tests have been added and passed. Yeah. Then we need to add something meaningful here. First of all, we will get the instance of the deployed contract in the migrations. Wait, token for 1, 2. Deployed. But before, we need to import our artifacts here. Yeah, and we will check that the storage is exactly as we have set in our migrations. That means that the total supply is equal to 100, and that the Alice has actually, or the first account, or the deployer has actually balance of this total supply. To do that, we need to read the storage itself in this way. Let's call it storage wait instance storage. And let's import the package called assert. If you have worked with JS, you probably know about it. Yeah, and we will use assert strict equal. Yeah, I will read storage field separately. Const total supply storage total supply, and we will check that is equal to 1000. Yeah, and we will need to check the Alice balance. Probably expect that we can do it in this way. Alice record some Alice address. We need to get it somewhere. Let's say Alice address. Or we actually can get this address from the file if you wish. These accounts, for instance, accounts. So we will add const Alice address. Yeah, so we may expect that this record can be fetched by a storage ledger, but it's not true. It won't work if we just try to test it. Very weird. Why? Well, probably we will get this undefined here. Let's check it. Yeah. And also, yeah, so you see that it's undefined even though we had something in the ledger. That is because ledger is actually Michelson map, as you remember from our storage design. Let me show it. So ledger is big map, and that's why we want to load all the big map when the instance of this contract is created and when the storage is read. And in order to get some key from the big map, we need to call it with get. And it is a sync function because the value is read separately. Yeah, and now we will get this record. Yeah, as you see. Also, allowances is Michelson map. That's why if we have some values inside of the allowances, we would need to get its values with another get request. And now we will just add an extra check for balance of the Alice. Yep. And we need to ensure that it is equal to 1000. Let's make this check. So our first test is done. Do you have any questions related to this part of the lesson? All right, I see no questions, so I think we can proceed to the next test. And if you will have any other questions, we will answer to them later. So let's add another test. I will just copy it. That will check the transfer. And actually, we will send some tokens from Alice to Bob, and ensure that the balance from Alice have decreased, and the balance of Bob increased, and the balance of Alice decreased. Yeah. So let's start with the operation itself. In order to call something, some function of a contract, we just type instance transfer and then provide the arguments. First, we need to specify from address, which is Alice address, and the next one is Bob address, which is the receiver of the tokens. And then we need to provide the value. Well, value we can just hardcode and say that value is 100 tokens. Bob address can be read from accounts that we have imported before Bob, right? We don't need total supply, I guess. And we will have Alice records after our action. And we will read Bob record. And then after the operation, and we need to replace address here. Bob address was run. Yeah. Bob address, Alice record, Bob records. Value should be here. So storage should be read after the operation. And now we need to update our results. We won't need to check total supply, but we will check the Alice records balance and Bob records balance. Alice record balance should be equal to 900, and Bob balance should be 100. So everything seems to be correct. We have an instance of the token, we have Alice address, we have Bob address here, we have some transfer. Yeah, so seems everything is just fine. And let's run it. Great. Interesting fact, we have an error in the line 25. That means that instead of 1,000 tokens, our Bob has in some way instead of 100 tokens, the Bob received 1,000 tokens. We can go to our code and look at the function transfer. What's going on here? It appears that yesterday we made a small mistake in this line, and instead of distance balance, we use source balance, and that's why the balance is actually wrong. So tests are really helpful here. And now we can fix this small mistake and ensure the tests are passed. And it didn't happen because, as you can see, compiling your contracts, they were not recompiled by some reasons. The reason is pretty simple, because we have split our contracts to two parts, and only if the main folder is somehow altered and the files in this folder have been changed, only in this case the contracts will be recompiled. That's why we will just remove our artifacts to make shuffle recompile our contracts. Finally, we succeed, and the test have passed, and we are pretty satisfied with it. We'll also add one more test. But by the way, do you realize what actually happened here, or do you have any questions related to this test? Is it possible to write scenarios including token transfers? Actually, that is exactly what we have done. Or do you mean XTZ transfers? If the question relates to the value of XTZ that should be included in the transfer, then you can just add an option here, value, and then specify the amount of XTZ that should be sent. For instance, and remember it should be done in XTZ, not in MUTES. I mean that this one means 1.1 XTZ and not MUTES. So yes, you can just specify the value of XTZ that will be sent along with your contract invocation. Yes, it's possible to check if the destination is an allowed list, and that is exactly what we will check right now. We will create an extra test case that will check the values. So I think we can just move to this test. We will create an extra test. Should fail, let's call it, if transfer is not allowed, or let's say approved. And we will remove all of it and assert rejects and add it to these rejects. If you do not know, rejects is the function for testing. Oh. That requires first argument is the promise that should fail. Next is the function that will check the error message. And if I'm not mistaken, let me check how our error message sounds. It's not permitted, right? And not permitted. And if everything is alright, then true should be returned. And if it fails, it also can display another message like no error needed. And basically, Here we can also add some error message like wrong message. Now we have the sender, and Alice is actually the sender of this transaction. So if we just run this test, we won't have any errors. And we will see this message, right? Yes, exactly. Missing expected rejection, no error is submitted. Well, also we can get another case when error message is wrong. For instance, when Alice tries to send too many tokens. And then this assert also won't work. So you see that the message is wrong, so that's not what we have expected. Then we have a question how we can generate the scenario when Bob actually is the sender and that's why he's not allowed to spend these tokens. To do that, we need to know that there is such a variable in the global scope is Tezos. It's not this one, Tezos. That is actually the provider, and that is the variable that is used in all these artifacts to call the transactions. And it is a part of Taquito that I had mentioned before, but as I said, I won't talk a lot about it today. So we can use Tezos to change the signer. Set signer provider. And we need to create a new signer here. Let me just remember how is it called? In-memory signer. In-memory signer. And so from secret key. And we need to provide the key here, which we can get from this file. But as you can see, we do not have in-memory signer. We need to install the package with it, which is called Taquito signer. It will take some time. And actually, we will need to import it from that package. Yeah, it's installed, and we can look at models and find this package in Taquito, I guess. Where is that? Yeah, Taquito signers, and we will be able to import it in our test. Yeah, it's resolved. So, yeah, actually, due to this action, we will change our provider that is read from truffle config. As you remember, we use secret key from Alice here. So everywhere, Tezos has signer provider has Alice as signer provider. So now we can just run our test as we did before and see how it works. Yeah, amazing. So the error message not permitted had been raised. The error with this message had been raised, and that's why we fetch it with assert rejects, and we see that the transfer won't be executed if the address is not permitted to do that. So do you have any questions related to it? I see something. No, I don't. I don't see it. So do you have any questions? So if there is no questions, then I think that Corney can talk about front-end integration and any questions? No? No. So then yes, Corney can continue our session and you will learn more about front-end integration and Tana's wallet and Chiquito probably, I don't know. Where can I find tested pre-built scripts for contracts? Not sure that I understand what pre-built scripts do you need for testing? Could you specify it? Oh. Do you test formal verification? I know that there is some tools, but I'm not good at them. You can look at archetype language for formal verification, but I'm not sure that you can use some frameworks for legal for formal verification.
Hey everyone. So I put a poll up that you can, if you look up on top on the right side of your screens, there'll be chat polls people or chat polls. Click on polls and answer the question. It should be, what Tezos wallet do you mostly use? And I've got there Thanos, Ledger, Galleon, Kukai, AirGap, Magma, and other. And I'd love to hear in the chat as well what the other wallet you guys use to store your Tezos, to store your Tez, essentially. So if you clicked other, go ahead and write which wallet you use in the stage. I'm just super curious to see which one it is. I know there's Zengo as well, so let's hear it. All right, atomics. That was something that I was considering putting there too. I figured that most people use that to interact with the DEX.